Okay, so hi everyone. We are picking up on slide number 10 here of our chapter 4 slideshow. We had reviewed slides 1 through 9 in chapter 4 earlier in the semester during one of our lectures. So we're picking up here and going over the remainder of the slides for chapter 4. So we're starting here on slide number 10. So, talking about the technical quality of assessments is where we really consider all of these aspects that we've previously discussed. We talk about the adequacy of an assessment tool to measure what it's supposed to measure, to be reliable, to be valid. We'll be talking about measurement error. And we'll be talking about the reference or the group standard as well. So we want to make sure that we are selecting assessment methods and assessment strategies and instruments that take into consideration the reliability, the validity, the error, and the reference group or standards. We want to make sure that we are selecting a variety of strategies to enhance all of these factors in our evaluations. This is one of the reasons why we use a multi-factored evaluation so that we can strengthen our evaluation methods by using a variety of different strategies and really getting the best of all that these different types of assessments and evaluations have to offer. Moving on and talking about some of the different types of measurement scales, um, we'll be going over nominal, ordinal, interval, and ratio scales today. Nominal scales are scales that divide data or divide scores into categories. So there are no values assigned to the categories. Um, it really would just group things, nominally or by name. So, for example, students with brown hair, students with blonde hair, it would group or categorize um, scores or information just based on some type of nominal characteristic. Ordinal scales divide participants and arrange them in a sequence. So this is where we would place individuals or scores in a relative position. So we would know who's first, second, third, and so on in terms of their achievement or in terms of their place in the normative sample. The thing about this type of scale, though, is that while we know the order of the individuals or the order of the scores, we wouldn't necessarily know anything about the distance between the individuals. So, for example, there could be a small amount of space or just a small differential in the scores between the first and second place individuals, and there might be a much wider gap between the achievement or the scores obtained by the second and third individuals in place, and so on. So the ordinal scale lets us know who's first, second, and third. It places individuals or scores in a relative position, but it doesn't provide any information about the distance between each of those individuals within the order. An interval scale provides equal intervals between the units. So, between the scores or the individuals that we're ranking, we do know that there are equal intervals or equal amount of space between them. So, individuals are ordered according to their scores, and the distance between the scores can be considered and discussed. So these scales don't begin with a true zero. The starting point is arbitrary. So, for example, if you take a test or a quiz and you would earn a zero on that test or quiz, that doesn't necessarily mean that you have zero knowledge or that you don't know anything. It just means that you got a zero on that particular instrument measuring your achievement. So, similarly, if a person gets a 50% on a quiz or a test and someone else gets 100%, it doesn't necessarily mean that the person getting 100% knows twice as much as the person who got a 50%. So hopefully that makes sense. The interval scale doesn't start with a true zero. So earning a zero on an assessment that is utilizing an interval scale doesn't mean the absence of knowledge or the absence of that specific skill. It's just an arbitrary starting point. So, most of the assessments and tests that we give in the context of special education are, in fact, interval scales. Standardized norm reference tests would be an example of an interval scale as we interpret standardized scores. That does give us information about where the child is achieving relative to other peers. So it gives us information about their relative position in that distribution. And it also does allow us to consider the interval between the units because there is that standard error of measurement and there's the standard deviation to consider as well. So that does, space things out evenly for comparison's sake. So most of the standardized achievement tests that give us a standard score are an example of an interval scale. A ratio scale is a scale that does begin with a true zero. So getting a zero on an assessment or some type of evaluation measure with a ratio scale truly does mean the absence of anything. Um, so this is often used to describe physical properties like height or weight, where 0 pounds truly means something doesn't weigh anything, or if it's something is 0 inches long, it truly doesn't exist. So that's just kind of an example of what a true zero would mean. So an assessment or an evaluation that's based on a ratio scale begins with a true zero. There are equal intervals between the units, and we can do arithmetic operations and statistical calculations with these types of scales a little bit more easily than some of the other scales that we've talked about. Some descriptive statistics that you need to know. These hopefully are familiar characteristics or familiar terms for you, but the mode is the most common score in a group or a collection of data. The median refers to the middle score in a set of data, and the mean obviously would be the average of the average score in the set of data. The range talks about the scatter of the data when we're looking at a group of scores or a group of students' outcomes or achievement on an evaluation. The distance between the highest and the lowest scores would compromise the range. So when we talk about the range of scores, we're talking about kind of that scatter and the difference between the highest and the lowest score in the group. Standard deviation is something that we refer to quite a bit when we're talking about standard scores. And this is a descriptive statistics that describes the variability in a set of scores. And in addition to talking about the variability, it takes each score's relationship to the mean into account. So the standard deviation gives you information about the variability and about where the child's score falls in relationship to the mean or the middle score in that set of data. We will talk a lot more about range and standard deviation when we administer the Wyatt, and I think that that usually gives students a little bit better of a framework when we actually start working with the test and you have some actual data to consider and interpret. But for now, just be aware that standard deviation does refer to variability in a set of scores, and it specifically includes the score's relationship to the mean. It kind of anchors and pivots all around that mean score. In a standard score, we'd be talking about a score of 100. So we're talking about how far above or below that mean score does a particular child's achievement fall. So measures of variability, again, I'll refer you to your text for a more thorough and comprehensive discussion and description of these measures, but I will touch on some of them here in the lecture. The first one to be considerate of is correlation, And this is the express degrees of relationship between two sets of scores. So it lets us know how similar or how closely related are two sets of scores or two types of data. So this is referred to often as the correlation coefficient or the Pearson R. I can tell you right now there aren't any test scores or test questions about the Pearson R, but just be aware that the correlation is about how closely an evaluation measures what it is intended to measure. It's a statistical calculation that lets us know how reliable and how valid a test is. The Pearson R value will range from -1 to +1. And the closer it is to +1, the better the correlation. So if you are evaluating different tests or assessments that you may need to consider giving in the future, always looking for that coefficient, that correlation coefficient. The closer to 1 it is, the better off you are. We often see strong evaluation materials out there that have a correlation coefficient of, you know, zero point 0.9, zero point 0.8 something, anywhere close to that perfect score of 1 is what we're looking for. And so that would be an indicator that that test has been shown statistically to measure what it's intended to measure, and that there's a high correlation between what it's supposed to do and what it actually does. So using that correlational data to evaluate the technical adequacy, or again to consider how good or how sound an assessment instrument is, we want to consider both the direction of the correlation coefficient and the magnitude. So the negative or positive lets us know if it's a positive or negative correlation, and the magnitude represents the size of the coefficient. Again, just be aware of these, not something that is specifically tested on the first exam. So I wanted to talk a little bit more about norm groups and standards. These are really important when we're talking about standardized test or standardized norm reference test. The standardized norm reference test compare an individual's performance to that of the individuals that were in the normative group. So the norm group should be selected to represent all of the individuals that will eventually be taking the test. So the norm group should really be selected to be representative of the population that will eventually participate in the test. So oftentimes, national test manufacturers will develop their normative sample based off of the demographics of cultural and socioeconomic and racial and ethnic background, um, individuals with disabilities and things like that, based off of census data. That's really considered the gold standard for a model of a representative normative group. But this is something that you want to know about and consider when you are evaluating tests for consideration and use in your evaluations, is to make sure that the normative group was based off of a representative and appropriate sample, so that we can be confident in our comparison from the student that we evaluate or test to the normative group or sample. So when we talk about norm reference tests, it's important to consider the age, the grade, the gender of the group members. So consider who was in that normative sample or that normative group. The method of selection for the group, it's considered best for there to be a random selection. Look at the representativeness of that norm group. Again, making sure that there is an appropriate and realistic representation of all types of individuals from various backgrounds in that normative group. Typically, the larger the size of the norm group, the better, and the recency of the norms. So this is one of the reasons why the tests that we utilize are there are new editions that come out approximately every 10 years. And one of the reasons for that is that the tests are renormed, meaning that they are readministered to a new normative sample because the demographics of the United States population do change, and the tests are renormed, reevaluated to make sure that they continue to represent current status of the normative sample. Talking about criterion reference tests, so these are tests that might be formal tests or they might be informally designed measures. So criterion reference tests are tests that will measure a student's performance or achievement not against a normative sample of other peers, but against a specific standard or expectation in the curriculum. So these tests really can kind of go either way in terms of them being formalized, published types of tests, or tests that you can develop locally as a teacher, as an intervention specialist, to find out information about the skills that your students may or may not have. So there are various curriculum out there that provide criterion reference tests as part of their curriculum to kind of query students for mastery of specific skills, but you can also develop these as a teacher. So criterion reference tests really can go either way, from a formal published type of test to a locally created, developed, more grassroots type of evaluation that can be designed by a teacher or an instructor. Again, the distinction here between criterion reference tests and norm reference tests is that in the criterion reference test, we are just comparing the child's achievement against a standard in the curriculum or a grade level expectation. So this helps us determine if a student has mastered or acquired a specific skill. And for these to be considered reliable and valid and fair assessments, the content or the standard needs to be relevant to the specific student and the specific situation. So we just want to make sure that what the test is evaluating is relevant to the assessment question, is relevant to the instruction that the child's received, and has obvious ties to the child's educational goals and goals and needs for intervention. Well, talking about the technical property of reliability, this is where we talk about consistency. So is a test consistent? Does it produce the same results under the same conditions over and over and over again? So when you administer the same measure to the same person, the evaluation results should be the same time after time. If that's the case, the evaluation is considered reliable. So at a minimum, for a test to be considered reliable, we want to look at a correlation coefficient of at least 0.8. Again, as I mentioned earlier, the closer we get to that perfect score of 1, the better. So a correlation coefficient of 0.90 is usually considered necessary for assessment data to be used in high stakes decision making, like determining if a child is eligible for special education, determining a child's placement in a specialized educational program. So we want to make sure that we really are using instruments to make these decisions that are technically sound and really are upheld to a high standard. So we want reliable, consistent measures for making those determinations and decisions. So the technical property of validity, again, refers to whether or not the assessment measures what it's supposed to be measured. And remember that validity does not exist in the absence of reliability. So something can be reliable without being valid, but validity and reliability always must go together. So if a test is valid, it is also reliable. But validity refers to if the assessment measures what it is supposed to measure. So, talking a little bit about this concept of measurement error, we've touched on this a little bit previously, but the standard error of measurement is defined as a statistic that quantifies the amount of error that's expected in the administration of a test. So, there's always going to be some level of error when we administer an assessment, and the standard error of measurement really seeks to quantify or place a numerical value on that error. The standard error of measurement is reported on tests in what is called a confidence interval. And this is a range of scores that represents the child's true achievement or true ability within that range. So we'll talk again a lot more about this when we talk about actually working with some achievement test data. Once you've had the opportunity to administer and score, we'll talk about working and interpreting with real data. So I don't want you to get hung up on this too much at this point because I do think it can be a little bit murky without experience. But just so that you know that standard error of measurement is a statistic that serves to quantify the amount of error that might be inherent in a administration of a test, and it is communicated in our scores in terms of a confidence interval. And that confidence interval gives a range of scores that surrounds the actual score we got, um, that accounts for that standard error of measurement. So that's really all you need to know about it for now. I think it will be a little bit more clear and make a little bit more sense when we actually work through the Wyatt and you have the opportunity to interact with some case study data and see how it plays out in real time. So, some examples of informal measures of student achievement include things like, um, ratio scales, which could involve things like frequency counts for collecting data. We use these often in evaluating behaviors. So, maybe counting how often a child is out of seat or how often a child uses a specific strategy. Those would be examples of frequency counts. That would fall under the ratio scale. Percentages, duration, these are all things that have a true zero and would be considered under the ratio scales. Some examples of informal measures that would fall under the nominal scale would be to classify or categorize skills that the child is demonstrating versus skills that they're not yet demonstrating, areas where they're at risk or they're established in their mastery of a concept. Some examples of informal measures that would be considered ordinal scales would be classifying a child's skills or a child's achievement as being at risk, having some risk, emerging, established. So we do this sometimes when we classify, curriculum-based measurement scores, or we talk about the child having below, at, or above grade level achievement. So again, really no test questions on this, but just wanted to give you some examples of how the ratio, nominal, and ordinal scales could play out when we're using some of those more informal measures for evaluating students' behavior or academic achievement in the classroom setting. So, norm reference test scores, we will spend a lot of time this semester talking more about norm reference test scores. We'll spend a lot of time learning how to score and interpret a standardized test. And I really think it will be then when a lot of this is a little bit more clear and makes more sense. But for now, just be aware that when we give a standardized norm reference test, the first score or first calculation that we get is what's called the raw score. And this is just simply a score or a number that talks about how many test items the child answered correctly. So we administer the questions under the standardized testing procedures, and the raw score is simply a calculation of how many points the child earned on that section of the test. But we have to do some conversion and we have to do some operation on that raw score to turn it into a standard score, so that we can consider the child's achievement relative to that normative sample that we talk about. So for now, the important takeaway It's just that the raw score is simply a calculation of how many points a child earned on the test, and we must perform an operation and a conversion on that raw score to get the standard score where we can start talking and having a dialogue, and consider how the child achieved relative to peers the same age. So the age or grade equivalents allow us to compare the child's performance to the normative group. We can typically, on most achievement or cognitive, well, I guess just achievement tests, in this case, have an age and a grade level norm that we can consider. So age and grade level equivalents are only useful to describe an individual's performance in relationship to the others in that group. So that allows us to talk about how the child did on that assessment in terms of how everybody else did, in that normative sample. So, age and grade equivalents aren't an indicator of individual performance, but they are an indicator of how the child achieved relative to other people in that group. So the percentile rank indicates the percentage of individuals in the norm group who achieved a lower, that achieved a raw score, lower than the individual. So we'll spend a lot more time talking about percentile ranks again when we get into working with the case study data, and you've had some experience administering the test. But for now, just be aware that a percentile rank really just describes the percent of individuals who took the test and achieved a score lower than this individual. So if you performed at the 95th percentile on an achievement test, it means that the score that you got is a higher score than 95% of people the same age as you got on the test. So hopefully that makes sense. The standard score, I just want you to be aware that, the standard score is a score that's derived from the raw score, on the test. But again, we do have to perform that operation or that calculation on the raw score to transition it to a standard score. And when we're talking about a standard score, we're talking about a score that has a mean or an average of 100 and a standard deviation of 15. So that means that scores that fall within the range of 85 to 115, are considered to be within the average range. They fall within one standard deviation above and below the mean. So that's just a very rote explanation of standard score and percentile rank at this point. But rest assured, we will spend a lot more time talking about this, as we prepare to work on our case study data, prepare for our key assessment, and writing our IEP toward the end of the semester. But just be aware of what the term means for now and know that you'll get more instruction and more opportunity to actually interact and, understand these using some real numbers and some case study information. So that's a wrap on chapter 4. Hopefully that was helpful. If you have questions, don't hesitate to reach out for additional clarification. Also, be sure to read chapter 4 in your text. It's a fairly, heavy chapter in terms of information. So if there are questions that emerge after you've listened to this PowerPoint or after you have read your text, don't hesitate to reach out, prior to the exam next week on February 6th.